Um, hey, this is this is the meetup number 11, I think. Yeah, this is the 11th time we've been doing this. It's really awesome. It's really great to see all of you. We do these like every weekend. And if you're new here, or if this is the first time you're watching these, then you should know that we have a Telegram channel where you can hear about all the next events and join them. That would be t.me/vrbitcoin. You can join there and just join our awesome community. And we have three speakers today from the Lightning Labs team. We have Lalu and Joost and Oliver. And they're going to tell us about LND 0.1, which is a new LND release.
It's not 10, technically.
Not 10, sorry, yeah. Oh, yeah, 0.10. That's an important distinction. So, so they're going to tell us all about that. And before we go on, I have just a small announcement. So I'm happy to say that Kraken, the Bitcoin exchange, are agreed to sponsor these weekly meetups. Cool. I'm really super excited about that because it's going to allow us to do cool stuff like, build custom spaces and build custom avatars. And actually, it will help us bring speakers who may not have access to VR equipment. So it's really awesome. And so before I go on, I'm just going to say a word from our new sponsor. So Kraken is the best Bitcoin exchange in the world for buying and selling Bitcoin. It has the tightest security, the deep liquidity, and a great fee structure with no minimum fees. And whether you're looking for a simple fiat on-ramp or futures trading, Kraken is the place for you. So as usual, we have a video camera right there behind us. If you want, you can wave hello through the camera. And we also, I will ask you, as I always do, to kind of stay in your places where you are, not move too much because it might be distracting to the speakers. So please try to stay where you are and not fly if you can. If some of you are like kind of trying to stand on top of chairs, so please don't do that because it might obstruct the view for the other people here. And yeah, this one, we sometimes do meetups that are like more technical and sometimes they're more like entertaining. And this one is definitely technical. I mean, they're also entertaining, but this one is definitely technical. And I think it might be a little longer than usual, but it's just a lot of great announcements. So I'm really happy about that. And as we said, we have Lalu, who's going to talk about the release in general, and we have Joost, who's going to talk about MPP, multi-part payments, right?
Multi-path,
yeah. And and Oliver will talk about PSBT, and then we'll do a Q&A at the end. And yeah, that's pretty much it for me. So you can just take it from here.
Okay, cool. All right, yeah, thanks all for coming. My first time doing a VR presentation, but it's pretty cool. Let me adjust this hovering screen a little bit. I think we're good. All right, cool. Testing out here, really done. All right, so we're going to talk a little about LND.10. So right now we're obviously I think in RC2. I probably tagging RC3 today. It's kind of like the next major LND release. Has a bunch of cool features, bug fixes, optimizations, all that type of stuff. It's not kind of talk about like some big ticket features or kind of like just very notable features in .10 itself. Obviously, there's a bunch of other features that you maybe want to check out before release notes when those come out. As well as usual, we'll have like a blog post, talking about exactly what's going on and the release itself and stuff like that. So I'll end. All right, so first we're going to talk about basically something that we have called like a new channel type. We call like Anchor Out. This is some work that was done by primarily Joost and also Johan on our team. We've done it over the past few quarters. So I guess kind of like one of the things I want to do first, kind of like talk about some motivation Anchor in general, right? Basically, right now the series of kind of like issues with ease on the Lightning Network in general. Basically, the way like main transactions work, right? So basically, today the initiator basically pays the fees for the lifetime of the channel. Oh, how did I? Okay, here it is, right? So basically, they pay the fees in that lifetime of the channel. So like, the initiator can actually pay the on-chain fees for the funding transaction itself. They're also going to pay the fees the entire duration of the channel it is right now, as right now. So obviously, it's a little bit simple, but obviously kind of like has some other issues as far as kind of like some incentives and things like that as well, too. Whenever you do a cooperative close, you're actually able to negotiate the fee, basically kind of like go back and forth. It's not really defined like super well in the specification. You can kind of like have some sort of kind of like satisfaction algorithm, which is kind of like inch towards your other party, to ensure that you guys eventually kind of like close things out. So one of the notable things, actually, whenever you force close on something like yourself, you force close your transaction, basically kind of like, you're broadcasting it unilaterally. Maybe there's some other issue that happened itself. You're kind of like locked into the fee of that interaction ahead of time itself, right? But this is a little bit different because now, like, typically when you're doing estimation, like whenever you broadcast something, you want to kind of like, estimate, at the time of broadcast, kind of like see exactly what's going on in the member, whatever else here. In this case, you actually need to like actually force kind of like guess ahead of time exactly like what the fee will be in order to get the transaction in blocking time, which is going to be an issue because like obviously like let's say like you were on for a period of time, the fees rose significantly, you wouldn't really get to upgrade your fee on that close transaction itself. And then typically when you're doing force close, you're doing it in order to actually be able to redeem some HTLCs. And HTLCs is kind of like this whole like multi-hop thing. Because there's a case where it's like if you can ever like if you ever filter redeem HTLC, like maybe like the case where the outgoing one, the one that I'm sorry, the incoming one, the one that you receive timed out, the outgoing one timed out as well, you could possibly kind of like lose the funds of the HTLC itself. So it's kind of like a big issue on this. I guess we'll take questions at the end, right? So I'm sure we'll have questions on this, but we'll do that. So then we basically created this new command type called anchor outputs, right? So as people know in Lightning, it's probably like the third command type we actually have in terms of like upgrading it. Because we have the OG one, we had one that basically make like something called as we call it like static remote key, and this one we're calling anchor output stuff, right? Command types is something that's going to be gated by the commitment new feature. Basically, it's like in Lightning, it's a ton of like actual hooks for people who need like a conversion upgrade, things like that as well. Basically, if you see someone that has this new feature bit, they say, okay, well, I have anchor outputs, you have it as well. You can actually use this new channel type and then go forward as well in the future on it. So basically, like, in a nutshell, all it is basically like, we now have like these two new outputs on the human interaction at all given time, right? So typically, base human interaction will have like two outputs. Now in this case, we have like four, right? So I have my coins go to me, you have your coins go to you. We both have this thing, but once again funded by the initiator. That makes sense because the initiator now only puts 660 extra into the channel in that given time, right? We call them anchor outputs because like what this does is basically use CPI or child parent actually anchor down the transaction. We call the name anchor. I think Johan is credited with the name on some like mailing list like 3 or 4 years ago. If you ask them about that. But yeah, so basically, in essence, now you can actually like decide on fees after the fact when to be broadcast, right? It's no longer the case that you actually need to get the fee rate correct to get to the next block. It's more okay. Now I need to get the fee rate correct into the mempool itself. Once in the mempool, I can then use CPF to actually adjust my my fee rate in time, and everything ideally going to be okay as well. One other cool thing we added in there is like we have like so it's not like just like a regular script. It's actually like a witness script hash script. It's going to be like reuse our multi keys. Also has like a new clause of like a 16 basically like CSV 16 blocks. The reason we have this is because now like, we actually ensure like any individual is able to pick up that those outputs to make sure that you take those that really have one of these like many outputs in there as well, right? We could like probably be writing these like scrapers. You can actually like check the blocks, check this like magic value of the output size, and actually sweep those coins yourself. Kind of like the one that you had in the past. This is kind of like a thing, but it's kind of like the protocols using that over time, which can then be swept by individuals or be swept by yourself, depending if you think the fee rate is proper or not. There's a bunch of other changes as well too. One of the quirks that we have in here is like basically every single path in the script itself now actually has like a CSV1. This is basically due to some issues discovered as far as like some like education like RBF or one period was written. Basically, otherwise like where an individual would get kind of like impede the competition transaction, and kind of like forcing you to very like long weighted transaction branch. Maybe we have to pay like a lot of fees up, and so there's some other like quirks in there as well too. But we're super happy we got the thing deployed. Right now, it's still kind of like pending in certification right now. But like we figured out it was far ahead enough time, also kind of like critical enough and upgrade, which will actually just get into LND in this new version itself. So now we're talking about some of the kind of like new things now that we actually did in order to make this thing actually work properly, and these are the things that you can actually use for other purposes as well, right? So we have something in LND called the sweeper. It kind of like supersedes something we had called use nursery. Basically has kind of like the same purpose. Basically, it's kind of like generalized like a pure like sweeping engine in LND in general, right? Because whenever you're doing Lightning, you actually have like two people on outputs. You have like your command output, you have your your HLC output, you have a bunch of things as well too. So we can basically give this to I got a message. Okay. We can basically give this to the sweeper and we'll just do its job, right? So we had a few different things. One thing we call like the force sweep because like typically if the output itself is 330 spreadsheets, you maybe that wouldn't really be economical, and the sweeper also makes sure that it's only sweeping output that's economical, meaning that am I back? I hit a button by mistake.
Yeah,
Okay.
I think your speed crashed the old space. My head.
My bad. Yeah, I thought I got kicked out or something. I was like, oh shit, I got banned. Okay, all right, I'm back. So force sweep basically an ability to kind of like force the sweep and output in those uneconomical, and then also something called super groups because like the way it is right now is like we don't really play off the mempool at any given point. So like there's like any given point is probably going to be 3 different command tracks actually valid. Basically, there's ours, there's one we sent the other party that hasn't been revoked yet, and then there's kind of like their one that's kind of like the depending on right there. So we actually need to kind of like anchor down all 3 at any given point in time because we don't really know which one's going to confirm. Basically, now communicate to the super. Okay, well. arbitrary distinct transaction, because otherwise you want to have like a max spend. Now we have a new gRPC plan to make it a little easier. Some people know basically we have something called like wallet a bump fee, which is basically kind of like something you can use to basically do CPFP across any transaction that LND can controls, or even become like an external channel. We then like made this cool wrapper called LND wallet bump close fee, which basically lets you kind of bump the close fee of a pending force close transaction yourself. And you can actually also do for cooperative close as well too. It's just kind of like gives you some additional stuff there. So basically, and as of right now, it's actually like an opt-in feature. You enable with dash protocol anchors. Basically, the way it is like it's kind of like a dual opt-in. So if I have the anchors bit set and you have the anchors bit set, then we're actually going to use this new feature going forward. And probably in the next few months, I think the other implementations are starting to now themselves too, probably become more of like an official thing. Right now, it's like an LND thing, but like we don't imagine it would change too much. And we also like work on some other features in the future, which can allow you to kind of upgrade your commitment type dynamically without closing your channel out. Next slide. Cool. Is it still there? Cool. All right, so our stuff. So as you know, like LND has like pretty good support for Tor right now. So one thing it has like aside of this is basically you can have something we call like a Tor v3 like auto hidden service basically. So if you just like add a few kind of like command line flags, it's gonna make a new hidden server for you. Everything will be fine. Tuning up the Tor daemon locally. So one thing we did, we actually kind of further abstracted like the way we actually store the private key in Tor itself, basically allow you to store this elsewhere. So you can imagine like let's say you want to have like like 3 LNDs, they actually all have the same hidden service. You may want to have that like actual private key be stored elsewhere. Maybe you can have like some distributed storage. That's one thing we did here. Another thing we did as well too, which makes it able to kind of like to have like Tor to kind of like have like more complex configuration with Tor and LND itself. And that supports something called hash passwords, which basically lets you kind of like authenticate the Tor daemon without using the cookie. You typically use a cookie, and in order to use a cookie, you basically have to like be in the same file system as the Tor daemon itself. This basically gives you kind of like a hash password thing, similar to what some other daemons use in other projects as well too. And one of the cool things we have now is we now have kind of like Tor support for watchtowers. So basically, similar to how you do for LND, if you have like this Tor active and then Tor.v3, basically that's kind of like your regular hidden server for Tor itself. Now we also have like watchtower active, which can now automatically create a new hidden service for your watchtower itself. Now, importantly, it's actually kind of like a new hidden service isolated. You have like a distinct onion address for this new Tor service, but like at least that's cool. Now you basically have your LND node. You can have like a Tor node, Tor tower node you can give to other, which you can then give to like your other friends, whatever else. Usually you have like the LND tower command, and you can check that out actually see what the new address is for your Tor node. Next one. Oh, I went back. Cool. HSC event subscriptions. So as people know right now, like we have something called LNCLI forwarding history. Basically, LNCLI forwarding history gives you kind of information about like all the past forwards in your node. So you basically use it to compute like the histogram of like the actual payments that you forwarded. You can compute like your free revenue and like all that stuff itself too, right? This is pretty cool. One other thing that lacks actually like has information of like any successful forwards. Basically has information about lacks information about failed forwards, right? One of the things that we realize like information about failed forwards can probably be very useful in order of actually kind of like optimizing your own node itself, because like failures tell you a lot more possibly than settles do itself. Failures maybe tell you where you need to like kind of reallocate liquidity on your node, or possibly maybe something where things going on as well too, right? Now we have this new subscriber HLC events call made by Carla and our team. So basically, it's pretty cool because now it gives you 4 different events, right? So it gives you a forward event. It's kind of like actual HLC circuit establishment, which is cool because now you can so like the other thing which is cool about this, you can use it to actually like time the amount of time between initially getting fully extended and actually one getting settled as well. It's kind of like the payment latency in the network itself. But we have a failed forward event, and so this is basically the case where like you took an HLC, we went downstream, but then somewhere downstream actually like got canceled back, maybe because some other issues that happened. Then we have the settle event, it's what we know it's normal, how it's going to accept. Then we have also like the linkable failure event, which is basically like something where we got an HLC in, we try to like forward it to another channel, but that channel rejected for some reason. Maybe the reason was like maybe insufficient key, maybe incorrect update policy or something like that. But like that's some other things there too. And one of the things it should be integrated into like our project called LND launch, kind of like this combination of input XP and what's sorry, not input XP, that's kind of like another thing. Prometheus and Grafana. So basically, it's ideally you have to kind of like have like a graph of like your actual HLC activity over time. So maybe you see like a burst at like 2 p.m. every day because people were just some particular thing. I think it's one of those tools that we really hope node operators actually kind of like hone in on their nodes, see exactly what they need to be doing as far as rebalancing, opening and closing channels, kind of like just like a little bit more information about as far as what's going on. And then we definitely want to make sure node operators have enough information to basically make intelligent decisions about their channels. Final one, RPC enhancement. So we definitely have a bunch of RPC stuff. I think these are kind of like the main things that I selected as kind of like notable. So one thing we have like a new version endpoint, right? Something people asked for in a while because like otherwise like So one thing is like, in LND, we actually upgraded the RPC system over time, and at times it can be actually difficult to tell, what exactly, what capabilities that node actually offers. Now we have a new version endpoint, which you can actually hit, and it's going to show you kind of like the Go version it was compiled to, used for basically reproducing our builds. People don't know we actually have fully deterministic, fully reproducible builds. So like on my Mac, I can build a binary that any of y'all can reproduce on any other machine that like we support, which is, probably like too many. Like we have like PowerPC and stuff like that on there. Then we also have the LND commit hash. Also the build tag. Build tags are pretty important because like the build tag is something we call subservers, which is these new kind of experimental servers, which will now actually be will be less experimental, I guess, in this new version, and also kind of like have these actually be on our main documentation that you kind of like in the community. But you guys will probably see on some of that a little bit later, right? Which is pretty cool because now anytime you have like a wallet application, it can actually hit this new endpoint version and see, okay, well, LND.10 added those new features. I can use that now compared to maybe if it were on .9, I'm not going to be able to use that at all. So it's kind of like something that like people realize was kind of like neat as we were making breaking chains a little bit earlier, like back in the day. We make breaking chains a little bit less appealing right now, but we still figure it's pretty useful. One other thing that we have in Lisp here, we kind of like have in my network connect, you send like an error to another peer. Maybe the error is like maybe it's critical, maybe it's not critical. Right? Maybe the error is okay, well I'm disconnecting. Maybe it's like, oh well, I don't like the HLC, or I think like commercial things or whatever else. But up until now, the error is always buried in basically logs. So if you have to like look through the logs, maybe you have some like grep, or maybe you have some other analysis going on there, but it's kind of like hard to actually find. Now we actually have something we have, it's kind of similar to kind of like a mailbox, right? So we'll be storing the last 5 errors that any peer sent us, and now this would be cool because now you can actually like look at a peer and see like exactly what messages were sent to you from that peer itself. One other cool thing about this, you can actually be using this kind of like rudimentary kind of communication channel between you and your channel party. So like I could basically say, hey, I can send you an error because I know you're going to store it that says, hey, I'm going to close your channel for 3 days because you're not being a good, node operator, basically, right? We can do that back and forth. Maybe some UIs will basically happen in the future. We'll see exactly what comes up with that. One other thing, we now have like pagination for list payments. This one thing because people don't know, but LND basically has this response limit for gRPC, which right now I think was like 5 megs or something like that. Pretty big block size there. The 5 meg response coming through there. But like, so what happens? Like people started reporting that it was like the inspiration when they had over 100,000 payments. So we actually then we had to paginate this thing, and now it's paginate similar to list invoices, which would be nice. Final thing, we have something called standard and unlock. Totally made it up. Basically, like up until now, the only way to actually unlock LND times that was do it possibly over the gRPC or kind of like interactively the way we have the LND library. We had a new command where basically LND can now accept certain parameters over standard in rather than kind of like having echo there. So this is pretty cool because you can actually use it to be like have like more complex situations, whereas maybe like using Docker, Kubernetes, or maybe have like hybrids or whatever else to actually make sure you can restart LND up on the fly without actually having to do any manual interaction on that end of things. Yeah. Cool. Yes. You gonna come over here? Should I go over there, or what are we gonna do? You're gonna stay there?
Yeah, I will come over here.
You're gonna all right.
Yeah.
So, all right, we'll swap. It's the station zone.
Okay. Yeah. Okay. Hello, everyone. So my part is about multi-part path. I think Ubi was already a bit in doubt, like, is it part or path? Like, both things are used so far. But now we're also adding the word shard. So I saw some jokes about the lightning also was sharding now.
We are sharding.
I would like to start with repeating the problem really. And this is a story which I've seen many times in real life meetups. People trying to pay with lightning in a bar, and they have a channel, like a 20 euro channel, and it's fine for paying for their drinks. And at some point they need to pay for dinner, and the dinner is 30 euros. So they think 20 euros is not enough, so I'm going to open another channel worth 10 euros, makes a total of 30. But they try to make the payment, and they have already waited for the confirmations required, and it still doesn't work. And then they realize that, okay, in Lightning, up till now, it is necessary to be able to make the payment in one shot, basically. So you can only utilize one channel to make the payment. So after opening the additional 10 channel, they need to open one more channel, a third channel worth 30, and use that to make the payment. And this is not a great user experience. And I think even before I even heard, the first time I heard of Lightning, there were already talks about multiple paths and make them atomic or not, but at least make a payment in multiple parts to get around this problem. So it's a very, very old problem already, and the solution for this has been anticipated for a long time. And the basic idea is that as a sender, you are able to split your payment in multiple shards, let us say shards this time, in multiple shards, and the receiver waits for all of them to arrive. And once they are all there, they will settle, the receiver will settle all those shards, and then it will get the full payment amount. And support for this on the receiver side was already added in LND 09. So in LND 09, the receivers running that were already able to assemble multiple shards, and other implementations they were a little bit ahead of us. They were also already able to make multipath payments, and also with LND it was possible to make a multipath payments using like manual send to route commands. So you weren't using the pathfinding of LND and the payment loop, but you could launch the shards manually. And now in 010 we finally added send support to our software. Yeah, so one thing to say about disassembling of sets, I think somebody also asked is this an atomic thing or not? And it depends on how you look at it, because once those shards start arriving at the recipient, they will all have the same hash. So once you have if you have the pre-image, you can settle them as soon as they come in. So in that sense, it's not atomic. On the other hand, if you are a receiver and you settle already in HLC while the full set isn't complete, what you basically do is that you reveal the proof of payment, but you haven't received the full amount anymore, and you may possibly never receive it. So there's an incentive there for the receiver to not do that. So even though they can settle the payment like non-atomically, it's not a smart thing to do. And what happens if you're waiting? So the recipient is waiting for the set to become complete, and so it doesn't always happen, because it could happen that one or two of those shards arrive, and there are a few parts missing, and they don't arrive. And what happens then is that a timeout gets into effect, and the recipient will cancel back those shards. So if you're making multipath payments, and for some reason the set doesn't fully arrive at the recipient, after a timeout which is currently fixed to 2 minutes, those shards will be cancelled back. So they won't be stuck for a very long time, but 2 minutes and you will have your money back. And sometimes it's also, it could be that you are resending those, let's say it like that. So suppose the first shard of the set arrives, and then the second shard arrives 1 minute later. It could be that because it took so long for the second one to arrive, that the first one gets cancelled. But what senders do, at least in the implementation that we made, is that those shards are retried. So as long as the sender still allows time to try to complete the payment, we will try to keep sending those shards and aim for a complete send at the receiver side. Next slide. Yeah, so this was a very simple example, so it's just sender receiver, but there are also other problems that we want to solve. So what could also happen is if you are a sender and you have like a big channel, has sufficient balance for you, but the recipient doesn't have enough total balance, but there's not enough total balance in a single channel. So it can also happen. You cannot make the payment. You don't really know why, because you can only see the balance of your own channels. And also in this case, it's useful to send a multi-part payment. And the third option is that both the sender and the receiver have enough balance in their channels to complete the payment. Only somewhere on the network there isn't enough, and this can be worked around with sending multiple parts again. So it's not just about completing a payment. It's also more efficient usage of capital. You can use your channels for you can utilize the capital in your channels in a better way, because you can take fragments of the payment amount. And it's also true that you can now send much larger payments, because previously the maximum size for payment was bound by the maximum size of the channel along your route. And pre-Wumbo, maximum channel size is 16 million sets, so a bigger payment that wasn't possible. And now with multi-part payments, you can easily get around that. So yesterday we just played around with some reg test, Oliver and me, and Oliver paid a 1 BTC payment with Lightning using, I don't know, 20 something channels or 20 something paths. So
I even succeeded with a 2 BTC invoice. So
it was on reg test, you said?
Yeah,
I think I got a 0.1 on testnet when I was testing out as well, so you can definitely get up there.
Yeah, so that's also quite interesting that you can now basically have an unlimited payment size. And another thing that you can do is you can perhaps get better fees or better time locks on the routes that you choose. Because previously, if you want to send a big payment, there's only like so many channels that are able to carry that. If you set a fee limit, if you set a low fee limit, what can happen is that you couldn't find any route that could carry it because all the big channels are expensive. Now it's not a problem anymore because you set a lower fee limit. Those big channels will be skipped, and then automatically, like the payment will be sharded, and smaller, cheaper channels will be utilized to complete the payment. And the same is true for like the reliability. So if there's a big channel but it has proven to be unreliable, also with sharding you can get around that and use multiple smaller, more reliable channels. Although there is also a trade-off, because if you launch multiple HLCs, there's also more risk that something goes wrong with any of those. And the final thing why you would want to do this is to obfuscate the payment amount. So if you are a node, you're connected to a well-known destination, you could sort of like see what kind of amounts are going towards the destination. And now you aren't that sure anymore, because you as a node forward, it could be just one shard of a payment that has a bigger total value. It also offers like better chances for smaller routing nodes. Even if you're a small node, you can participate in relay of the bigger payments. So then to how do we split? The splitting algorithm, a lot has been said about it already, but it's just a really difficult problem. If you look at like the graph that I have there, you know very little. Like you know the topography of the graph, you know your own balances, but you have no idea what the balances of all the network are. But even the capacities are just a lower bound because people can open shadow channels, meaning that they open like multiple channels that are only private, so they're not advertised on the graph, but they can also still carry payments. So you know you have very incomplete information. Yeah, and what could even happen is if you search for a path through this graph and you make a wrong decision, it could, and wrong means like it does arrive at the recipient, but maybe you spent a balance in some channel on the network in a way that prevents you from getting the second shard to the recipient. So there's also the dynamic interaction between like multiple of your own HLCs that you send out. So that's also makes it harder. And then suppose an attempt fails. Well, what do you know? So the thicker lines is the path that we chose. So there's a failure between R3 and R5. We try to pay 20, so at least we know that that connection can take 20. All the connections before that can take at least 20, and from R5 to the recipient we still don't know much. So if you think about the optimal solution for this problem, it's just very, very, very difficult. One other reason why is that if shard succeeds, no feedback is given. That's like a current characteristic of Lightning. If you send a payment and it arrives, but the recipient is holding it, it's similar to HODL invoices, then you won't hear anything back. So it could be that this payment got stuck along the way, or that it reached the destination, you don't really know. So if you're making an NPP payment, you are sending those shards, and if your HLCs get stuck, it's actually a good thing because they are held by the receiver. But it could also be that they are not held by the receiver. So that's another thing which is difficult. It also means that you need to launch those HLCs concurrently. You can't launch the first one and wait for it to arrive, because they'll never tell you. You have no way to figure out that it actually arrived. So you need to launch them concurrently, but you also don't want to launch them concurrently too fast, because otherwise you don't allow the system to return failures to you, which can be useful to plan the sending of your next shards. And then there's optimization goals. It's not only about completing the payment, but you also want to optimize for fees, for time lock, reliability. Maybe you even want to rebalance as you go, basically. So try to pick the channels and make the payment through those channels in such a way that your channels end up more balanced than they were before you did this. And finally, the pathfinding algorithm that we have, it works backwards. So if you think I want to spend 10 through this channel, in the current implementation it's not really possible to do that, because we start at the recipient with the value that we want to deliver to the recipient, and then we switch backwards. So you end up with like a different value. Maybe it comes out like you need to pay 12 to get 10 to the recipient. So you don't, like the code at this moment doesn't have like full control over how much you send out through every channel. I think there's quite a lot of information, but just to highlight how complicated this problem really is. And first we had the idea, okay, let's see how far we get, but very soon we said, no, we're not going to see how far we get, we're just going to do the simplest thing that is possible, divide and conquer. the halvening, another halvening in Lightning, and it means that if we fail, we're just going to try again for half the amount. So it's like very contrary to all the complexity that I just tried to explain. The algorithm that we implement is very, very, very basic. And to make it clear, I gave an example here. So there's a sender, they have enough liquidity, they need to pay the recipient. They want to pay 28, and they have no idea that between R1 and the recipient there's a 10 and a 20 channels with balance 10 and 20. So the first try will be for the full amount. So they try 28, it will fail. And then they try for half that amount. So they try for 14. 14 succeeds, meaning that, and now I'm at the second bullet, is that the 20 channel goes down to 6. So we have two channels then, 10 and 6. We try 14, it fails again. We try 7, it succeeds. Then we are at 3.6. 3.6 we try 7, it's also not possible anymore. We try 3.5, it succeeds, and so on. And in the end, we completed the payment, and we had 4 failures and 5 successes. So we sent the payment in 5 HTLCs, while theoretically you could do it also in 2. You could send 10 and 18 and it would also be fine. But the thing is that we are not only planning this payment, but at the same time we are basically probing the balances of those channels on the network to figure out what they can carry. So this is far from optimal. But it does work for a lot of cases. The only thing when this gets a bit more difficult, if the payment amount is very close to the theoretical maximum, because it's not optimal, the algorithm has like difficulty to find that to find a solution. And we still have to see how often this is going to happen in practice. Everything here is like super new. I have no idea how it's going to work out. The design space, the problem space is huge. So it will be very interesting to see what feedback we will get on this first attempt. And also to keep this whole halvening a little bit in hand, we added 2 restrictions. So we set a minimum shard amount. So we're not going to split down to the single Satoshi. At some point we just stop splitting and we say, okay, if it doesn't work now, we just give up. It's currently set at 10k sets, so your shards will never be smaller than 10k sets, unless there's just a remaining amount for your payment that's less than that. And the second thing is that you're able to control the maximum number of shards. And the reason for that is that if you wouldn't have a maximum, it could happen that especially if a lot of channels, that we launch like so many payment attempts at the same time through different channels, that creates problems of its own, which I also explained before. We don't get any failure info while we already launched like a whole bunch of attempts, and that's also not good. So ideally, this is not like the max shards. It's not a parameter that you want ask the user to set. But for now, because we're at the very beginning of like this field of research, really, we just expose it, and we'll see how people will use it. So one other thing is, because so much is happening now, there are like multiple concurrent attempts that can fail. New attempts are looked for. It became necessary to provide better feedback. Even during development, it was just hard to figure out, okay, what's happening now? Does it work or doesn't it work? So there are 2 things that are currently available. One is still a PR, but that's an improvement of LNCLI that allows the send payment or the pay invoice command to give a bit better feedback. I also tweeted about this. So instead of like spewing like huge amounts of JSON, it will print out the table, and every row in the table is the HTLC, and it shows what the status is. So if it's in flight, or is it finished, like succeeded or failed, and the failure message with route was taken. So it gives you a better feeling of what's going on if you make a payment, and in particular a MPP payment. And the second thing, this is in one of my own repo. It is a repo of my own. It is like a visualization tool that can take the output of list payments or the output of send payment. This output describes all the HTLCs when they were launched and when they were resolved, and it creates a timing diagram out of that, which is also very useful to like see what's going on and to investigate particular issues. So final thing is I want to talk about like multi-loop out, because a very exciting possibility that is opened up by multi-part sending is that if you now loop out, you can do this with multiple channels at the same time. So you start I am now assuming that everybody knows what loop is. Should I do that? Yeah, maybe not. So what is loop? So what you can do with loop is you can change the balance of your channels. Basically, you make a payment to the loop server, and this will shift the balance in your channels, allowing you to, in the future, receive money again. And the money that you pay to the loop server is sent back to you on-chain in a non-custodial way. And currently, this is only possible channel. So you send out one payment across one route, and you get it back on-chain. And meaning that you also need to pay chain fees for that single channel loop out. So you get the money back on chain, you need to sweep that, so it's one chain transaction for that. With multi-loop out, what you can do is you have like a bunch of channels and you use all of them to make a single Lightning payment to the loop server, and you get it back also in a single transaction on chain. But with that single on-chain transaction, you have looped out like lots of your channels. Suppose you are a merchant, you've got 20 channels, they all got depleted, meaning that people kept paying you until you could receive no more. Then with one loop out request, you can basically loop all the balance out of those channels, push everything out to the loop server indirectly, and then receive the money back on chain. Even you can receive it even directly into your exchange deposit address. Yeah, I think this is it.
Cool. Over here?
This is everything I wanted to say about loop.
Thank
Yeah.
Yeah, I just want to go to the podium over there.
you.
Take your thing.
Over there. Yeah. Sorry. Yeah, I'm in 2D space, so.
Yeah, he's in 2D. I'm the only one actually in VR. You can see my hands. So.
All right. I think it was Marty who wrote in his band that 2020 would be the year of PSPT, and I agree. And this is our part we're doing with LND 0.10. You will be able to open channels using PSPT. It needed some preparatory work in 0.9. Lalu added some features that were necessary to make this possible. Also, we needed the library that was finally merged in BTC Util, the PSPT library by Adam Gibson, and these two things allowed us to make this feature work. On the user interface, it's pretty small. You only get the new flag -PSPT to your open channel command.
That's what I'm feeling.
And that will launch into an interactive dialogue with the command line, and it will tell you what to do, and you will interact with it, and finally give it a PSPT. I decided not to do a live demo, but there's an example, the documentation in the repo as well. So if you go to docs, then PSPT, you can play through that.
Nice.
It's pretty cool on the command line, but this will be much more useful if it's automated through the gRPC interface. So we hope that a lot of wallets will make use of that. It's also a bit because of the
so guys, sorry, I've been chatting with my designer that's working on my NFT for.
Reason is that we actually start the negotiation with the remote peer when you open a channel, and we pause that process, and the peer will time out after 10 minutes. So just keep that in mind. But I hope that won't really be a problem when using this.
Yeah, it's taking back a lot of time.
Yeah, especially if you can automate stuff, it should be plenty of time. Yeah. So
and then one cool thing automation-wise, you can actually use to open multiple channels in single transactions. So you can actually use a PSPT, several times over. Basically, maybe open 10 channels in one transaction, which is also pretty cool. Feature-wise.
Yeah, got that on my next slide.
Oh, my bad. Well, you can add. We'll think with another example.
Okay, yeah, well, but what is a PSPT? Maybe not everyone knows. It's a BIP, of course. It stands for partially signed Bitcoin transaction. It's a standard format to exchange information about the transaction that you want to create. And it allows wallets to cooperate on the process of assembling and signing a transaction. And because the design space there is quite big, the creators of the BIP decided to create roles that you can, as a wallet, as a software, you can take. So there's a creator that creates the thing, you can update it, you can sign it, you can combine multiple PSBTs, you can finalize the inputs, assemble all the witnesses, and then finally extract the raw Bitcoin transaction. One part of it is an actual wire format Bitcoin raw transaction, which is step by step being more complete. And then the other thing is that for each input and each output, you can add additional information. It's kind of a TLV-like format that has a few standard data types, like you can add the actual UTXO that is being spent, you can add the derivation path of an input, you can specify the SIG hash type, what scripts are being used, which is, all these things aren't really in a transaction itself. These are all additional information that the participants need to complete the transaction. So the partial part is very important. Not only the partial signature, but also the partial like input and output list. So let's go through an example. Let's say you have a hardware wallet that has all your funds. You have a Bitcoin D that has only the XPub, so has only public keys, but it knows all the UTXO. So it knows the chain, it knows the fees, and it knows all the derivation path, but it has no keys. And you want to use these two to open a channel in LND. That's exactly what we used in our example use case. So we'd go ahead, tell LND, hey, I want to open a channel with a peer by using PSBT, and it would then give you the instructions and what to do. So it would say, okay, now go to Bitcoin D, tell it to run this command, and then you go to hardware wallet, whatever. And in the end, you have a finalized PSBT. You give that back to LND. It will extract a transaction and actually publish it, and the result is, yay, an open channel directly from the hardware wallet. As Lalo already said, this allows for multiple cool use cases. One of these is batching. You can open multiple channels. This is already partially implemented by the command line, so you can specify a previous PSBT that you want to add your new channel output to, but you can also automate this to open a whole bunch of channels. And with that, you can also spend directly from a multisig output. You could even take the loop out sweep and push it directly into a channel funding. What I think is really cool with what Jos just explained about multi-loop out, it allows for the merchant zero balance scenario where a merchant has a hardware wallet. It opens a channel from that hardware wallet. The closing transaction will also go to the hardware wallet. They receive money during the day. End of the day, they loop everything out, and in the evening they have zero hot balance on their LND node. And they can do that every day. So it's basically like emptying the cash register every day, and a robber or an attacker that comes at night wouldn't have any funds to get, right? So it's pretty cool. It also allows for some privacy features. So if you think uniform output sizes and batching, you get the idea, right? We also, or I have to say, Lalo also has many plans on how to spin this even further, that you could have a pair of LND nodes. So one is completely watch only. Everything that needs any kind of private key or signing is abstracted away behind an RPC interface.
Have a pair
And
of LND.
this is the node that's publicly connected to the internet that talks to the other nodes. And then there's a second node that's hardened, firewalled, whatever IT security measures you can think of, that is not really connected to the internet and only has the hotkeys and answers the signing requests from the other node. And it would add a small delay, but we think it's possible to do this. So you could actually be more careful about all your hotkeys. And of course, everything that touches the chain would be done through PSPT, which also allows it to be much more integratable into other wallets. And we also plan to implement more of the PSPT role more into LND, so that the LND wallet can do all of these functions, that we can also do the whole funding, fee estimation, whatever in LND.
Mm-hmm.
Yeah, that's it from my part.
Cool.
I think we now have time for a Q&A.
Yeah, it's like
Thank you
my
all
slides
for
died.
listening.
I wasn't sure if y'all could still see it, right? 'Cause mine died. I don't know what happened.
Oh, like your browser window, or?
Yeah, it's just like white. I was gonna refresh. I wasn't sure it was gonna like actually mess yours up. I guess I'll refresh now.
Okay.
Guys, thank you. This was awesome. And just one small complaint. Some people were saying that Joost and Ollie were speaking too slow. So maybe
Yeah, sorry
maybe
about
we can
that.
try
I'm
it.
trying to. It's really hard because.
No, it was awesome. It was awesome. Thank you. So what we're gonna do now is everyone in the crowd is going to get a special button on the bottom right of your screen. You should have a
this is
raise
great.
hand button appearing, and you can click that if you want to ask any question. And I'm just gonna people. Yes, it is. I mean, you can just speak. You don't have to ask permission.
I'm just,
So
I'm just testing it out.
So let's start with Bitcoin. It's JC. JC, go ahead.
Hello. So I had questions about the first part, all of the changes to the HTLCs and the sizes. Is that partially an attempt to prevent some of the like theoretical attacks that I see people talking about, where they try to like DDoS all the nodes, or is that just basic optimizations?
Well, I mean, so it's similar. You can say much features that we added in this new format actually make it much easier depending on this in the future. Because if someone tried to boss the node and make them all force closed, they would kind of like be locked into that fee rate, at that particular point. But now this thing actually increase their fee rate to get to the block or do whatever they want to. So basically, it gives you a lot more fee control. Because as of right now, you kind of have to guess ahead of time what the fee should be whenever you're force closed. And now you can actually you can basically lowball it now and then use CFTP to bump it up progressively. While before you kind of lock into that fee rate, because that's not good, because obviously the conditions on mempool and it's going to change injection and stuff like that.
And one more quick question also about I'm having a brain fart now. About the lower limit for if the fees get higher than the channel balance itself, does that also help with the FAT since you're locked in at a lower fee? So let's say you've got a channel for $30 and the fees are like $25.
Mm-hmm. Yeah, I mean, so in this case, you can actually have the fee be much lower, and then kind of if you don't really care about it, actually go on chain later on. The other thing was this is only for force close. So basically, whenever you actually force to broadcast on chain, meaning maybe there's an HLC that's about to time out, or the other party's offline basically. So this is kind of the emergency case, and making sure the emergency case is able to actually bump the fee up to get into the chain in time if you really want to. Also generally you can say there's probably you should generally lower fees as well too, because now you're no longer trying to guess the fee of the next block. You're guessing the fee to get to the mempool, which is a lot less volatile basically, and typically a lot lower. So
Okay, great, thank you.
yeah, no problem.
Cool. So next question from Waxwing. Go ahead.
Hey, can you hear me, guys?
Yep.
Yeah, great. Yeah, thanks for the presentation. It was great. I was wondering, it's a bit of a vague question. What's the current status as you see it of dual funding? I've seen some discussion on the mailing list about some, anti-DOS aspects of it, but what's the
good
status?
question. So I think Well, yeah, I mean, so I'm not working on myself directly. I think kind of like Lisa from Sea Lightning, working more directly herself. Like to my understanding, I think like they're worried about some issues, like you're saying about kind of like making sure that like you can't code down to another user basically, by kind of like doing repeated dual funding attempts, seeing all their inputs, and also possibly kind of like making sure if you're actually providing an input, the input's unspent, you basically have a kind of like a proof unspent and things like that as well. So it seems like there's some other issues, maybe as far as like kind of like privacy issues, we're kind of like holding it back right now. But on the upside, like you can actually use this, use stuff today basically to simulate dual funding, actually having two channels, right? So I have one to you, one to me myself. Obviously, it's not as good because you actually have two outputs, but that's kind of like a holdover until people figure out like whatever they're comfortable with as far as like the mitigations on the dual funding side. Like, as well too. But so I think so. There's like a PR open in the spec repo. I think Slating also has another PR open themselves. I think maybe they can look to get into their next release in an experimental format. But yeah, I'm not sure from there. But you can simulate dual funding if you care about if you're cool with basically having two outputs versus one. So that's like that. So
Sorry, can I just clarify? You're suggesting the idea that you would dual fund in the sense that you would share inputs, but you just have two separate channel outputs. Is that what you mean?
Yeah. I mean, so like theoretically, with what we have right now with PSBT, you can actually like have a single channel open single transaction open two channels in both directions. Right. So it's giving one to you, giving one to me myself. Now we're dual funded, quote unquote. So you kind of like have an initial starting state, but obviously like as time goes on, maybe the channels get a little more unbalanced. Maybe you need to do things like looping, whatever else to get that in that particular state. Obviously, the advantage of doing it like the proper way is you have like a huge section of the chain basically versus two. But it's kind of like okay, here versus there, satisfaction, everything. So no problem.
Awesome. So next up, Matthew. Go ahead, Matthew.
Well, can you guys hear me?
Yeah. And if you can show an emoji so we can see where you are.
Yeah.
I think I see it.
Yeah.
Great.
Yeah.
Question for Juice. I'm just wondering what happened to the TLV shop.
Oh, TLV shop. Okay, it's not my ambition to be a shop owner really. It was just a demonstrator. We did quite a few stickers, but it also started to taper off. It wasn't as new anymore. The internet is bored pretty quickly, so I took it down to get back to get rid of that like extra thing to worry about.
Okay,
but I mean, I guess you could have another version with the YAML stuff.
Yeah.
Right?
Yeah, I just wanted to add that there is a PR like in the works at the moment that really allows you to do this yourself, because for TLV shop I still have to fork LND to do like the interactive keysend acceptance, because currently in LND if you accept keysend payments you'll always accept them, and for something like TLV shop it's very important to carefully inspect all the records, see is the order correct, is the address correct, is the amount correct, and only then you settle the HLC, otherwise you'll cancel back, because you may otherwise end up with like getting money and you're not able to send out the order. So that PR is coming, and I think that is like a very important building block in order to build similar like services yourself.
Yeah, perfect. Thank you.
Yeah.
Great. So next up, Evan, go ahead.
Hey all, can you hear me?
Yep.
Yeah.
Okay, cool. So on the mailing list, Boz mentioned that there's potentially breaking changes with the API in 0.10.
Yeah. So basically what happens, like, so, the stuff we mentioned with, MPP can only be using something we call like the router RPC server, which is kind of like previously like an experimental RPC server. So this isn't kind of like the main one using right now on the Lightning service. This is basically another one. Well, what happens is basically kind of like, did some changes to that new experimental one. So like, if you're using kind of like the main RPC server, like everything is fine. If you're using the one with a little more bleeding edge, you may need to update your code. It was kind of a thing where like, we envisioned that like we were actually like change it over time because we weren't really sure exactly how MPP would look like on the kind of like, RPC level interface wise. But now that's the thing. So basically the response has changed. If you're using that new RPC server, if you're using the old one, then you're fine. But we do want to migrate to this new one because the new one's each other, and the new one will be a lot more stable going forward. I don't know if you have any other things to say on that, guys. I guess not. Okay, he's just standing. So he could.
Sorry, no. Yeah. No, nothing.
Like,
nothing
because you're in 2D, like, it's a lot less emotive, right? Like you're just standing there while like everyone else in the meeting is like looking around and stuff.
Yeah. The only thing to add there is so subservers have been experimental so far. They still are really, but it's a bit unclear to us how many people actually rely on this. So the impact of this change is still to be seen. We also very interested to get feedback during this RC cycle to see what people think of this change.
Now, is this change going to have an effect on the REST service as well?
There is no REST service yet for router RPC, so no.
Yeah.
Okay.
But
Gotcha.
yeah, like once it's kind of like more grown up, there will be a REST service, and Oliver done some work as well, kind of like to make sure everything is covered on that. But yeah, so it's kind of like a newer, more bleeding edge thing. But now we're trying to like progressively make it more refined and more stable, so you don't have to use it for all these new features.
Cool.
Yeah, so that's an important thing as well. Like if you want to do multi-part payments, you need to use router RPC now. It's not enabled in the main RPC. It's like an incentive to move over.
Gotcha.
And currently an incentive to use gRPC because the router RPC is, as you said, not in available in REST yet.
Yes, good point.
All right. Thank you very much.
Awesome, thanks, Evan. Looks like this is the last question, unless someone wants to pop in. Yeah.
Yeah,
Okay,
I have a
great.
question about
Who's me? Who's that?
me, Ollie. Sorry.
Okay.
Alu,
Go ahead,
question
Ollie.
about anchor outputs. Does that mean we don't do fee updates anymore at all in anchor output channels?
No, that's a good question. So, like, so it's kind of the thing, similar to measure that we're actually probably going to give leads for later time. But like right now, we do still do fee updates. But like basically, the ideal one is like you do a fee update and you kind of like have like a much more lax fee estimate, basically. Like rather than like maybe like 2 or 3 blocks, you have like maybe like a 20 block, something like that, right? Right now, we still do that like shorter term estimate. For the future, we're going to have a mechanism where like after you do manual fee updates themselves, we're still like kind of like a fee update ceiling in that channel going forward. So right now all the capabilities are there. We're not being fully utilized as they could be because we're still kind of like doing the updates that we're doing legacy format. That makes sense.
Okay, because that would be like also like a cool security feature if you could say, yeah, I only make outgoing payments to this channel. There are no fee updates. I know I'm always on the latest like channel state, right? So it's harder for me to get breached. Right?
Sure. Yeah. No, you can definitely have that in. That makes sense. Yeah.
Cool.
For sure.
Awesome. So, guys, thank you for this. This was awesome.
Over here.
Thank you, Udi. It was great to
this is definitely
host this. Thank you.
Thanks for
this was great, guys.
Thank you.
Thanks to Lalu and Yost and Ollie. This was awesome. Thank you guys for coming. Thanks to Desiree too, who's from Viking Labs here in the crowd for setting this up. This was great. I want to also say thanks to our moderators who are helping us in all of these events. We have JC here. We have Gigi in the back. I don't see him right now. Oh, here's Gigi. Hey. And Ben the Carman. So thanks, guys, for helping. Hey. And thanks for Kraken for supporting these events. And I guess what we're going to do now is, well, usually what we do after these events is go to VR Chat, which is another VR app that's like more free form and we can like just hang out and have fun. And we're going to do that. And if you guys feel like joining, then please do. It's a lot of fun. But I think I'll let like about 20 minutes to stay here because I know some people can't join on VR Chat. So we'll just stick around here. I'm going to unmute everyone. And you have voice. Hey.
Hey, Desiree.
You can even go on stage.
Hey, how are you?
I'm good. Thanks very much for this. And thanks for the call on next week.
Yeah. I put on the calendar yesterday, so yeah, thank you for making that easy to set up. Looking forward to it.
Yeah, indeed.
Your avatar looks like you.
Yours doesn't.
Elizabeth was like, "Which one are you?" And I was like, "I'm the robot."
Yeah.
But your hand movements, like, I can tell it's you by your hand movements, honestly.
Yeah. Nice movements.
There's actually like thumb tracking and stuff like that.
So why is everybody playing Animal Crossing? I do not get it.
Oh my
Yeah,
god.
it's just.
What don't you get?
No, help me understand. So what is it? I mean,
Well,
do you just
I mean-
like plant? Do you just like plant a thing and then get a bee?
It's escapism.
Well, I mean, it's more than that. I mean, it's you know, it's one of those games that has like no set goal. You make your own goals yourself. So it's like, you know, like me, I wake up sometimes, I go to the orchard, you know, I get the cherries, I sell the cherries, and then I just stop playing, right? And then so you can do as much as you want to basically. So it's like Minecraft and The Sims put together, kind of. And there's like some like, you know, fishing and stuff like that too. Like,
Send me a cherry tree.
What is the ultimate goal? Is there a goal? Like something you're
there's no
supposed to
goal. Like,
actually
there's no
do?
goal in Minecraft, right? You just do whatever you want. You build whatever you
I
want.
don't
Same thing with Animal Crossing. You can like make islands. You can like, you know, make clothes. You can like catch all the fish. Like in the sea.
Okay. I need to get that.
Guys,
game
it's
for my
just
wife.
like life. What's the point, really? Like, when you think about it.
Yeah, I'm waiting for the VR version.
The VR version of Animal Crossing.
Oh, Animal Crossing, like that's what I'm saying. Like, if Nintendo did VR, this would be like 100x better, right? This is do VR. I think if they do, to make it. I'm holding it.
Same here. I
want a quest.
shamefully started yesterday. Shamefully.
I want a quest so I can play VR on the couch and
Still
stuff.
trying to pay off my house.
What's that?
I was saying I want a quest so I could play VR on the couch. I think it'd be a lot more.
Yeah,
convenient to
I'm
play
like
that
in a
quest.
wheelchair right now, so I'm just like moving back and forth.
I'm in a wheelchair, but I have to get my